Good morning, everyone, and welcome back to 61, 67, 81, 67 Network Security course. In the previous week, we start to introduce the CDN and ICN, so Information-Centric Network or Content Distribution Network. So basically, we try to introduce a potential of redesign of the Internet so that we focus on the content delivery instead of the from host to host delivery. Okay, so we have introduced some of the content, and now we advanced to the topics related to the security of CDN network. Okay. Actually, we started to discuss about this thing, and if you recall, there are several things. When we talk about the security, we focus on three features, C, I, and A. A is integrity. A is availability. And C is confidentiality. The availability is actually CDN network will provide a very good improvement to the availability because now a lot of the content will be buffered along the path from the client to the server. So the availability is definitely a very good feature from the CDN's point of view. Integrity, we mentioned that the data's integrity should be provided by the digital signature of the original source of the information. For example, if this is a Sony Pictures movie and the Sony Picture should have a digital signature upon the content of the movie. From this point of view, the integrity is protected by the signature, not necessarily protected by whoever is the provider of the data. So if there is a router or a buffer or a cache on the intermediate node between you and Sony Picture, if they already buffer the data, they will be able to provide you the information, and you will be able to use the digital signature to verify the integrity. Okay, and the major concern when we leave in the previous session is about confidentiality. In other words, there are a lot of data needed to be delivered encrypted. Okay, and if it's encrypted, then we face a lot of problem. Because if we buffer the encrypted data, then we face a lot of problem whether or not you will be able to provide the key to the nodes along the path. If you do not, then we will have to buffer the encrypted data, and we will have to deliver the data in the encryption format. Whoever is along the path will not know the content. On the contrary, if you give the encryption key or decryption key to the intermediate node, you face some data disclosure problem. Okay, so in this session, we will try to discuss the pros and cons of different approach to this problem. Okay, and before we directly discuss the CDN or ICN network, let us first look at a simplified, or not necessarily simplified, an intermediate system between the traditional TCP/IP network and the CDN network, which is the Akamai content delivery network. Okay, and we will draw a simplified network scenario. Okay, if you recall, in the previous session, we used to use Amazon Video on Demand as the example, and then we figure out that Amazon has its own cloud front, which is also a CDN, so I highly doubt that Amazon will now, well, Amazon probably still use some service of Akamai, but Amazon obviously has its own channel. But let's say we use Hulu, and in the medium between you and the user, there is Akamai. Okay. Okay. So this is the simplified scenario. The user wants something from the Hulu, and then Akamai is in the middle, can buffer the data. Okay. And if you recall, in the previous class session, the first thing we discussed is, hey, first, will the data be encrypted during the transmission? In other words, when the user wants a movie and the Hulu deliver the data to the user, will the data be encrypted during the transmission? If I have to take a wild guess, I will say yes. Because you can imagine if there are movie data flow in the internet unencrypted, there will be a lot of theft of the data and a lot of piracy related attack, because if it's not encrypted, I will be able to capture the network traffic and store it in a file, recover the video file, and then I can redistribute it without your permission. Okay, so yes, we believe the data is encrypted. And now we need to ask actually the second and the third question. These are closely related. The questions are, will Akamai, in other words, will the intermediate data buffer store the data? Well, we know that Akamai will definitely buffer the data, right? That's how the content delivery procedure helps to improve the system performance. Will Akamai store encrypted data or clear text? Or clear text, okay? And if Akamai store clear text, then that is easy. So basically somehow Hulu will provide the movie to Akamai. I mean, when we say provide the movie, it's not encrypted, it's clear text movie. So Akamai can directly play it on any major video players. If it's clear text, then Hulu somehow provide the clear text to Akamai, and when Akamai send it to the user, it will re-encrypt the file. Okay. The other way is Hulu will directly provide to Akamai the encrypted data without the key. Without the key. If it's without the key, what does that mean? That basically means Akamai cannot open the encryption result. Okay, Akamai will not know what's going on. Akamai, based on the tag provided by Hulu, it will know, oh, this is the movie, The Last Samurai, minutes 6 to 10. I only know that. I will not be able to play the video because it's encrypted. So basically, I will know this is The Last Samurai, minutes 6 to 10. This is a file. Unfortunately, it's encrypted, so I cannot play it. But it does not matter because the user just wants to watch the movie, so I can still forward this data to the user. Okay. So let's consider the different scenario, and we will then read the Akamai document and see what's going on. It's a very interesting solution, I have to admit. Okay. So during the class or during the previous session, we believe that Hulu will not give the key to Akamai. This is we assume, okay? Hulu will not give the encryption key to Akamai, so Akamai will see this data but will not be able to decrypt it. And then let's see what will happen. Okay. If this is the assumption, and if the assumption is true, okay. So first, the user 1 asks for data. So basically, user 1 said, hey, I want to watch the movie. It suddenly somehow started to function weirdly. Okay, so user 1 asks for data, so user 1 will log in to Hulu, and Hulu will actually verify his or her identity and send the data to the user through Akamai. Okay, so the Hulu will encrypt the data and give it to the user. Okay, remember, if it's encrypted, that basically means there is a key. There's a key involved in this procedure. So this is a data encryption key, and it will send to the user, and Akamai will buffer the information which is still encrypted. And at this moment, Akamai will not be able to decrypt the file. Okay, and then through some other channel, Hulu will deliver the data encryption key K to user 1. And of course, this procedure also needs to be encrypted. What does that mean? That basically means, hey, Hulu cannot just send the key K in clear text to the user and say, hey user, this is the key, and this is the data encrypted with the key. Okay, if you are sending this, that is basically meaning that, you know, you encrypt your credit card information, and then, well, that's a bad example. It's the same as you put a big yellow sticker on your screen said, this is my username and this is my password. Okay, that it will not help you to secure this information anyway. So you cannot send the key K in clear text. You need another one, let's say K2, to encrypt the K and send to the user. This is the secure channel. This is the secure channel between Hulu and user. Okay, so in this way, user will be able to recover this secret key K and then open the data and then start watch the movie. Okay. So now you may ask me the question, well, this does not solve the problem. That just push the problem one layer upper, right? Because, oh, you cannot deliver the data, so you encrypt the data. Now you cannot deliver the key, so you encrypt the key. So now the question is, how can K2 be generated? How can we, generate a K2 securely so that the Hulu and user will understand each other? And of course, this you should refer to what we discussed in the 6200 course, the Principles of Information Security and Privacy. A very straightforward approach is to use Diffie-Hellman mechanism between Hulu and the user, and each of them will generate a random number and jointly determine the key K2. Okay, so now let's look at this procedure. This works so far so good. Okay. This works so far so good because now the user get the data no problem because it's encrypted, and also the user also get the secret key K through a secure channel. So the user will be decrypt the file and actually start to play the video. And now let's see what Akamai got. Akamai got the encrypted data. And of course, based on the tag, Akamai probably know what the data is. Okay, we just say this is the minute 6 to 10 of the movie, The Last Samurai. However, Akamai does not know the key K, so Akamai cannot open it up. Okay, so let's say what user 2 will do. Okay, so user 2 will also want to watch the same movie, the same segment. So the user 2 will contact Hulu and said, hey Hulu, I want to watch the movie. And Hulu will say, okay, no problem, and I will only give you, okay, this is, So at this time, the user and the Hulu again will use Diffie-Hellman to determine a secure key, which is called K3. Okay, I understand this is a little bit off because this is user 2, but the key is called K3. Okay. So using Diffie-Hellman, Hulu and user 2 can jointly determine a key K3, and then Hulu can encrypt the data encryption key K. Remember, this key K is the same as this key K that Akamai buffer the encrypted data, delivered through a secure channel to the user 2. Okay. At this point, the traffic between Hulu and user 2 is very minimum because it's only a whole bunch of, it's a few like, it's more like a handshake procedure, and you generate and exchange a random number, and you got the key. Okay. So now the user 2 will get the key K as well. And then what? Then Akamai will provide the data to the user 2. And remember, the same data is encrypted by the key K, so user 2 will be able to decrypt the data and start to play the movie as well. Okay, so what does we mean? So this is one solution we figure might be the solution that Akamai adopt between the service, between the cloud, between the content server and actually the end user. Okay, we actually have two keys. We have a data encryption key and the key encryption key. Okay. In this specific example, the data encryption key is key K. It is used to encrypt the data, and since the data involve a large volume of information, if we have to take a wild guess, I would say this is symmetric encryption algorithm. And then we have the key encryption key. What are they in this specific example? They are K2 and K3. Okay, so these keys are used to encrypt the info. These keys are not directly used to encrypt the data, but to encrypt the key K. Okay. So why do we these two levels of keys instead of just a single key? The reason is we want the content buffer or cache to store the data. Okay, we have the data encryption key, and we can keep this the same. This does not need to change. And then for every user, we will generate a new key encryption key so that we can deliver the data encryption key K to him or her, and then give him the same copy of data, and he or she will be able to start to play. Okay, so in this way, we guarantee that the data is private. So basically, Hulu never need to disclose the content of the data to Akamai edge server or content buffer. Okay. Whatever is in the data is private to between Hulu or between the surface and between the client. Okay. In the middle, this guy will not be able to decrypt the data. The overhead, of course, is every time the user still needs to contact with the server directly and get a copy of the data encryption key through a secure channel. Also, this involves a little bit, so basically you cannot directly get your service from Akamai. You have to first contact the Hulu and get the data encryption key, and then Hulu can provide you the content. Okay, you can see the large volume of data is still buffered at Akamai, and as the disadvantage, you still need to contact and establish a communication or a connection with Hulu's server to get the key. Okay. This actually may slow things down a little bit. Okay, so until now we introduced what we think. What we think might be a possible solution between Akamai and the service provider like Hulu or Amazon. Okay, in the next video we're going to see whether or not Hulu is really using that. Surprisingly, Akamai has much larger leverage power to force the content provider to open to them. Okay, but we will save save it for the next session. Okay, thank you. See you in the next session.